Okay? For this video, we're going to tackle the assignment model using the Hungarian technique or the Hungarian method. Okay? So, to solve an assignment problem. Normally, assignment models are used. The objective for assignment model is to minimize the cost. But for this problem, iba. Okay? So, we have here the Panda company just developed a new dishwashing liquid and they are now preparing for a promotional campaign on national television. Okay? So, what they have decided on is that they will place commercial, 1 minute long commercial during the peak homemaker audience viewing hours of 1 to 5. So, may target market sila. The homemaker. Ang viewing habit, so you know your customers. Okay? So, their target market are the homemakers and they know the habit of the viewing habit of the homemakers. Nanonood sila from 1 to 5 p.m. So, to reach the widest possible audience, Panda wants to schedule one commercial on each of 4 networks. There are 4 networks. And they want to place one commercial appearance during each of the 4 1-hour time blocks. So, the exposure ratings for each hour, which represent the number of viewers per $1,000 spent, are presented in the table. So, this is the table. Okay? So, $27.1 dollars. Hindi pala yan dollar. So, 27.1 ratings per $1,000. Okay? So, halimbawa. So, dito yung maximum exposure. So, first, we transform this since assignment models are used to minimize. So, we first transform this into an opportunity cost. How? By identifying the highest value in the entire table. Okay? So, ito yung highest value. So, we subtract all these numbers to the highest value. Okay? So, we do that. So, 27.1 minus 27.1 is 0. Okay? Then, 27.1 minus 18.9 is 8.2. 27.1 minus 19.2 is 7.9. 27.1 minus 11.5 ay 15.6. Okay? So, we did the same for the other columns, no? So, ito na yung resulting opportunity cost table. So, 27.1 minus 18.1, you get 9. Okay? So, 27.1 minus 11.3, ito na yun. So, binuo ko lang. Okay? Then, from here, we identify the lowest value in each row. Okay? So, the smallest value in each row, 0. What else? 8.2, 7.9, then 5.7. So, we deduct the smallest value to each number in each row. So, 0 minus 0 is 0. 9 minus 0 is 9. 15.8 minus 0 is 15.8, then 17.6. Pagdating naman dito, so 0, 8.2 minus 8.2 is 0, 11.6 minus 8.2 is 3.4. Okay? Then 1.8, 8.2, 10 minus 8.2 is 1.8, then 16.5 minus 8.2 is 8.3. Yun nga, the smallest value in each row I determined, tapos ibabawas natin yung lahat ng values to that smallest value for in each row. So 9 minus 0, 15.8 minus 0, okay, 8.2 minus 8.2, 11.6 minus 8.2, then 10 minus 8.2, then 16.5 minus 8.2. Okay? So ito na yung resulting table natin. Next ay we identify the smallest value in each column. So the smallest value dito ay 0. Dito ganun din 0. For this one is 1.8. Tapos dito ay 8.3. Then we deduct. Okay? So that becomes ganun pa rin 0, 0, 0, 9.9. So walang change kasi 9.9 minus 0. Diba? So dito naman ganun din. Wala ring change. Okay? Here, meron. Okay? 15.8 minus 1.8 is 14. Okay? Pagkatapos, 9.3 minus 1.8 is 7.5. So 1.8 minus 1.8 is 0. 9.3 minus 1.8 is 7.5. 4.6 minus 1.8 is 2.8. Tapos, we have 9.3, 0. 17.6 minus 8.3 is 9.3. This is 8.3 minus 8.3, 0. 11.5 minus 8.3 is 3.2. And 8.6 minus 8.3 is 0.3. Okay? So, we now check whether we have an optimal solution. Paano natin gagawin yon? So, to test for optimality, we cross out all the zeros with the least number of lines. Okay? So, how many zeros do we have? Ayan, meron tayong 0 dito. We can cross that out with the least number of lines, ha? So, therefore, it's 1. Pagkatapos, ito. Yan. So, dalawa ng 0. Then, ito. Okay? So, the number of lines must be equal to the number of rows or column. We have 4 rows or 4 columns. Kailangan din for assignment models dapat square yung table mo. 4 rows, 4 columns, o 3 by 3, 4 by 4, yan. Okay? So, as we can see, the number of lines, we're able to cross out all the zeros with only 3 lines. And the number of columns is 4, so they're not equal. So, it's not yet optimal. Hindi pa yan ang katapusan. Hindi pa yan ang dulo. So how do we do that?